All right, so now we are going to be looking on the isomers, right? So we're going to be looking on isomers or structural isomers. So these are compounds that have the same molecular formula, but structurally they are different, right? So the molecular formula is really just a count of how many of each atom we have in there. So they have the same molecular formula but different structural formula. They have different structural formula due to the different arrangement of the atoms in the space. So we are going to draw isomers of C4H10. I know it's already on the handout, but we are going to practice how to draw isomers. Drawing isomers. When we are drawing isomers, the first thing we want to do is to draw all the isomers, all the carbons in a straight line. That's the first one we're going to draw. Then, when we are creating different isomers, we are going to, yes?
Miss, I can go back.
So we're drawing isomers. Isomers, the first one we want to draw is to make sure all of them are in a straight line. And then we put our carbon and our hydrogens there. Then the next thing we're going to do is to reduce the number of carbon in the longest chain. So first one would be the longest chain. We're going to reduce the number of carbon in the longest chain. And then we're going to add the carbon on any other carbon. So we're going to add the extra carbon on any other carbon except the first or the last carbon. So we're going to add the additional carbon on any other carbon except the first or the last carbon. So we're going to practice, and we can continue shortening, reducing the number of carbon until we can get no more, right? So we're going to draw isomers of C4H10. In this compound, we have 4 carbons. So the first isomers, and this only have 2 isomers, we're going to draw all 4 of them in a straight line. Then we know it's an alkane because C4H10, so we know that it have 2 extra hydrogen. So it's an alkane. So I go ahead, make sure each carbon is bonded 4 times. What's the name of this molecule? What would be the name of this?
Butane.
Butane. So that's my first isomer. Now I'm going to shorten my longest carbon chain. I am going to shorten it. I am going to be shortening it. So 4, if I shorten it by 1 carbon, how many carbons would be there?
3.
And it says put the additional carbon on any carbon except the first or the last. In this case, where can I put the additional carbon?
In the middle.
Then I'm going to make sure each carbon is bonded 4 times. What's the name of this? Longest carbon chain is?
Propane.
4.
Do I have a substituent?
Yes, miss.
What's the name of the substituent?
Methyl.
And methyl is on which carbon?
Second.
So the 2 isomers of C4H10 are butane and 2-methyl propane. Clear? Are we clear?
Yes, miss.
Those who are doing this for the first time, Malia and Martin, we're good?
Yes, miss. Yes, miss.
All right, so now we're going to draw and name some isomers of C. So we're going to draw and name some isomers of C6H14. I'm gonna do, it's a 3. I'm gonna do 6. isomers. So the rule says I must make sure the first one I draw is in a straight line. Clear? Clear?
Yes. Yes, miss.
Okay. So I'm gonna go ahead. Why my camera like turn on? I'm gonna go ahead and draw that one. So each carbon will have, I'm gonna make sure each of them is bonded 4 times by adding in my H's. What's the name of this?
Hexane. Hexane.
This would be
Hexane.
Hexane.
clear. Everybody draw hexane.
Yes, miss.
Right? Then the next, so I can reduce the number of carbon in the longest chain. So let's say I reduce it to 5. So I'm gonna reduce it to 5. Where can I put my additional carbon? On any carbon except the ones on the end. Clear? Except the first or the last. So my carbon can go here or here. Clear? So for this isomer, I'm gonna choose to put it. So for this isomer, I'm going to choose to put it on the second carbon. Clear? Clear?
Yes, miss.
All right, let's go. 1, 2, 3, wrong pen. 4, 5. Then I'm gonna make sure each carbon is bonded 4 times. So the name of this isomer, my longest carbon chain has 4 carbon, 5 carbon. So it would be pentane. Where's my methyl?
And the second carbon.
So I can still have 5 carbon and this time put my carbon where? Where would I put my other carbon?
Miss, on the third carbon.
Good. And make sure each carbon is bonded 4 times. Longest carbon chain, 5, so it's pentane. I have a methyl substituents, and that methyl is on which carbon?
The third carbon.
All right, so I'm going to, so I've exhaust 5, because if I put it on this carbon, it's still the second carbon. If I put a carbon there, it's still the second carbon. So I've exhausted 5. I am now going to reduce the number of carbon in my longest carbon chain now to what?
4.
So now I have carbons, I can put them on like that. Any carbon except the first or the second one, or 4 carbons and then put both carbons on the second one. Clear? So these are 2 additional isomers. All right, let's stick to 5 isomer. Let's see if I get no more than 5. Won't get any more other than the 5. All right, what's the name of this isomer? Try to name it first. This one or this one? Let's do the top one first. Longest carbon chain of 4 carbons, so it would be
Butane.
substituencies.
Methyl.
How many of them?
2. Dimethyl 2.
And they're on which carbon number?
The second and the third.
So it's 2, 3, dimethyl butane. And the last one would be longest carbon chain. Oh, I don't finish put on the H's. Let's put on these H's. Longest carbon chain is
Butane.
substituencies. Methyl. We have a methyl here. And we have another methyl here. So it's 2 methyl. So it's dimethyl butane. And which carbon number are my dimethyl butanes on? Both of them are on the same carbon. So it's 2, 2 dimethyl butane. Clear?
Yes.
All right, so you are going to draw and name 2 isomers of C7H18, H16, sorry.